Hello, I'm Rob Higuerita, and I'm an enterprise support lead at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Mike Wells and Aiden Bekarov from AWS Support. Can you give us a quick introduction, Mike, and then Aiden?
Hey, I'm Mike Wells, a technical account manager based out of Colorado. And as a technical account manager, I get to proactively monitor my customers' AWS environments and assist with proof of concept initiatives and address real business outcomes. I also coordinate access to programs and other AWS experts as needed. Technical account managers are both technical and business focused to help AWS customers get the best value from AWS services. Aiden?
Hi, I'm Aiden Bekrov. I'm an enterprise support lead in San Jose, California. So echo everything Mike said there. And I'm really interested in continuously improving distributed applications and microservices, and Step Functions is a great help in that regard. And so I'm excited to share some knowledge and support customers better. So yeah.
Great, thanks for the introduction, Mike and Aiden. So today we'll be introducing you to AWS Step Functions. We'll specifically focus on getting you information on what AWS Step Functions are and how to use AWS Step Functions to accelerate development and simplify your workflows. Before we get into the details, though, a quick note to the attendees online. Please feel free to use the chat window on the right-hand side of your screen to share your thoughts and ask your questions throughout the episode. We really want to hear your interactions and your questions today, so we look forward to it. Aiden, can you go ahead and walk us through what we're going to be talking about today?
Yeah, totally, Rob. So we'll cover the key use cases for workflows as in steps, which your application or your process is going through. They will cover the key benefits of using AWS Step Functions, and we'll cover how to actually build these workflows and to meet actual business needs, and the different types of workflows for different challenges that Step Functions can offer. And lastly, getting started and next steps. And we'll also do some demos along the way. And yeah, that's the gist here. So let's jump into it. Why the effort in modernization? Modernization is a business priority today. You need to keep up, and the major perks that Step Functions provides are basically everything that serverless environments provide for you. So, Step Functions is a serverless function orchestrator, and it makes it very easy to sequence like AWS Lambda functions and multiple AWS services into, actual business critical applications. It's a serverless solution really for orchestrating business workflows. And the benefits here really, like adapting at scale. What this means is, from zero to peak, you don't have to over provision. You only need to provision exactly what you need to satisfy our customers, delight your customers. This means lower costs, not only for you, but for your customers. And, you pay for exactly what you're using. It's, and resources are optimized on your behalf. And what this really translates into is, getting your idea to market faster. You eliminate a lot of operational overheads, and you can release your features quicker. It also has a lot of other benefits, like of breaking your applications into service components or steps, right? That ensure that failure of one component doesn't bring the whole system down. You can scale each component independently, and that components might be updated without requiring the entire system be redeployed after each change. So all of this translates into a better customer experience. Over to you, Mike.
Yeah, let's jump into a real world case study. I studied about Lego recently, and Lego started their serverless journey in 2019 whenever they migrated their e-commerce website to a serverless platform on AWS. In 2020, the Lego team focused on acceleration and looked to AWS Step Functions to help. Lego uses AWS Step Functions to address two different business needs on their e-commerce platform. First, they have a product catalog feed for Lego.com with thousands of products across tens of countries, and they needed to take that product data and publish it to different consumers like social media and back-end applications. The key here is that the platform that serves their customer is also the platform that they'll use to run their own queries. And that means that for each country, they need to perform a large volume of queries without overloading the platform. Step functions allowed Lego to easily control and smooth out the number of parallel queries that they performed at any given time. Another area where Lego took advantage of step functions was empowering their online recommendation engine. As product feeds are updated and fed to the recommendation engine, there are some that will inevitably fail. But step functions enabled Lego to automatically manage the reprocessing of only those failed feeds without missing a beat. Aiden, why don't you tell us a little bit about workflows and how those help, and what exactly this is?
Totally. So, workflows are all around us, really. It's also, let's start with data processing, a very common example. Like, data is everywhere, right? And organizations that take advantage of this really differentiate themselves by developing new and compelling experiences for customers to gain some competitive advantage, right? Data is diverse, and it comes from varying sources, like mobile devices, your actual applications, marketing and sales data, external data, operational data stores, like your infrastructure generates data as well, your logs, and more. It's basically looking at how to be data driven and break down data silos to gain insights. And that is the reason with data processing is the first example I want to talk about. I mentioned here like media processing, unstructured data processing, real-time order processing, batch processing, and each of these has their own steps of massaging the data or cleaning the data or collecting or preparing, and so that is a great use case for step functions. And so let's put that out there. That's a great use case for it. And you'll see as well a lot of the service integrations really lend themselves to this. Like, for example, later we'll talk about how EMR and AWS Batch Elastic MapReduce and AWS Batch are integrated directly with step functions. Next, machine learning, very similar. There's a lot of workflows there, in order to build, train, and deploy your models and actually have them providing meaningful insights and predictions for you. There's a lot of steps in that as well. Microservice orchestration or distributed apps, the services need to talk to each other. They need to be able to handle failures, as you mentioned, retries, be it Lambdas, be it containers, be it like a human step of approval. That's also involved in orchestration. And lastly, like security and IT automation can have a lot of workflow steps in it as well. Like access management. If a employee is asking to break glass and help in an emergency, you should be able to have this workflow kind of audited, visible, and provide that insights. Business case, even like a credit application, if you're a credit card or a financial company. Or even like your CI/CD pipelines, that is a series of workflows that you can integrate with step functions. So there's a ton of different workflows that can help you out with this. I guess, Rob, do we have any questions from the audience yet?
Hey, thanks, Aiden. We don't have any questions from the audience right now, but I do have a question. You're talking about the different workflows and just kind of curious about the properties of some. For standard workflows and some properties of express workflows, like, can you take advantage of both options, or how does that work overall?
Yes, you can. So depending on the challenges you're facing, like standard workflows and express workflows, asynchronous and synchronous, we're actually going to have a slide later on that explains this in really good detail. But short answer, yes, you can mix and match and meet the perfect needs. And I'll definitely do that question justice in a few slides later, Rob.
Great, thanks, Aiden. Appreciate it.
Let's talk about another case study. Most people have heard of Thompson, and they have a lot of publications and a lot of TV channels. And if you consume any news at all, it's probably hard to get through the course of a day without reading some of their stories or watching some of their video clips. They did have a problem not too long ago. They have a lot of incoming videos, which is usual. The incoming clips, fortunately for them, are all in the same format. So unlike many media companies, they don't have too much of an input conversion problem. However, they vary wildly in length from like a 3-second clip to a half-hour long interview with a newsmaker. And they need to convert this for delivery, and this is news, so they need to do it fast. And historically, they used FFmpeg, which if you're in the biz, or it's what everyone uses. The problem is that it's single-threaded. So if you want to transcode a half-hour video, you can easily end up waiting a half hour for that video to be transcoded. Well, it turns out if you look at a stream of video frames, some of them are special and they're called keyframes. And results show that the actual video processing time of each segment is pretty much static, around 3 seconds to half a second per segment. And the initial identification of keyframes within the source video does depend on the size of the source video, and you have to tick through the whole video to identify the keyframes. We're currently doing a little bit further implementation to make this stage more efficient to save any more time, and this could feasibly take the processing of any video down to a few seconds. So what we do in this case with step functions is break the process up and parallel process rather than processing this all at once. So in this way, we can break down the processing of video from a 20-minute processing time to be able to transcode it down to 2 minutes, which is fantastic. Another use case is about NuData, and NuData is a AWS customer that uses AWS to help customers fight fraud and protect customers online. They were acquired by MasterCard in 2017. NuData is a Canadian startup and just started using machine learning to detect and prevent account takeover and fraud. NuData uses Amazon SageMaker to improve the detection of fraudulent activities like credential stuffing, and they use a host of services, but they orchestrate them all with AWS Step Functions. And this simplifies the machine learning architecture and optimizes its training workflow. Through these improvements and through using AWS Step Functions, they were able to reduce the time it takes to develop models by 60%. Rob, there's a case study from this. If you, hopefully I gave you the link. If you could post it in the chat for anyone who wants to follow up more about this. So Aiden, why don't you tell us about how the application orchestration works?
Totally. Mike, I just wanted to call out like your Thompson Reuters example, like just how wild that can be. Like you can scale to thousands and thousands of Lambdas, instead of scaling, EC2 instances, right? Like it's so much easier to scale Lambdas and have step functions orchestrate it for you, and make sure like the right output is coming out of these keyframes. Yeah, that's huge. I think I've seen even other blogs where you can cut down like, from hours of work to like a minute or around that time frame. So it's all about what you want to scale that concurrency and that parallelism to. But yeah, super cool example. Yeah, thanks, Mike. So orchestration, application orchestration, it's pretty common for modern cloud apps to be composed of many services and components, right? You might be familiar with the term loosely coupled microservices. That helps build an app as a suite of small services, like each running in its own process, each independently deployable. In an application, different microservices need to communicate with each other, depending on what they're trying to achieve. And like let's pretend you're trying to find restaurants open for delivery, and that's a totally different set of microservices needed, that you'll communicate with when you're trying to place that order. So that's a good example. Like and as your app grows and you got an increasing amount of code that needs to be written just to coordinate the interaction, deal with retries, deal with failures, of all these components, that's really where like managing these simple workflows, these actually and complex workflows with step functions can be very helpful. So yeah, they let you focus on your actual business components, instead of writing all the software and the glue to make that interaction work. That's orchestration we're really talking about here. And container orchestration, you can orchestrate. I know I talked about Lambdas a few times, but you can also orchestrate containers. Like for example, we even have serverless AWS Fargate tasks, right? You can upload your container, with one or many services in it, and that can be orchestrated as well, direct integration. And same goes with the Lambdas. Like if you're building many different Lambda functions, each with a function independently. So that's it in a gist. That's the orchestration we're really talking about here, and I can't wait to show you how it actually looks with the visual workflows and stuff like that. But Rob, I guess any questions, Rob?
Hey, so we don't have any questions specifically, although we do have kind of one back from Rancor Bro. Welcome back to the show. They're kind of looking for ways to get away from like using proprietary software that renames files and dates. So that sounds like a good fit for using step functions, being able to orchestrate kind of some automated actions.
Definitely, I would say so. Definitely, like I have an example later on where we have like a file upload sequence, and it does some work with like Textract, another like managed SaaS product, and like actually having a Lambda function to rename these files for you, or maybe kick off like another trigger for you. That's a great use case for like, let's call it like data processing. So I'm going to say strong yes as an answer.
Great, thanks, Aiden.
So Amazon provides a great way to be able to handle these workflows through AWS Step Functions. And AWS Step Functions is a serverless function orchestrator that makes it easy to sequence AWS Lambda functions and multiple AWS services into business critical applications. Through its visual interface, you can create and run a series of checkpointed and event-driven workflows that maintain application state. The output of one step acts as the input of the next, and each step of your application executes in order defined by your business logic. So you can actually run these and actually see the process moving through each one of the different states as it moves through each different decision point and you can, Aiden and I worked through our example and we saw different failures as we were going along through, and it made collaboration so much easier because we could both look at the same screen and see exactly where in the process each one of these different states failed. Orchestrating a series of individual serverless applications and managing retries and debugging failures can be challenging. As your distributed applications become more complex, the complexity of managing them also grows. With built-in operational controls, Step Functions manages sequencing, error handling, retry logic, state, and it removes significant operational burden from your team. I know that we also integrate with so many other things. Can you tell us about how all this stuff works? Like go into a little more detail about the Step Functions.
Totally. So, basically, like a workflow can be as simple, as simple sequence of steps, like we're seeing on the left here. Like we're just doing a very basic, upload of a raw file to S3, for example, like a customer receipt in this case, right? And that's just a simple task. That's the state that's going on here. Very basic, and then immediately delete it. Like we just want to make sure that we're just testing the plumbing here, right? That's the simplest example, just a very linear set of steps here. You can also involve like branching logic, right? Depending upon what happens earlier in the workflow, or in the very right hand side here, like you can have parallel workflows where you're doing a number of different steps at the exact same time. The results are independent, like they're not related to each other, and that's you can take this even further. Like these are all this example here. If I walk us through it, we basically invoices are scanned, right, loaded into an S3 bucket. Upon loading, like Lambda triggers Amazon Textract, and that's a fully managed machine learning service to automatically extract the text and data from the scanned invoice, right? And then Step Functions is used to process the results of that Textract job, right? And this extracted text can be like the combining of the services can give us our automated loading into the database. And quite simply, I just want to explain like we have a choice state in the very middle, like select image converter. Like, do we want to convert to like JPEG or RAW, right? For example, we may stop an execution if there's a failure or a success. That could be like a fail or success state. All of these end in a success. And, or we simply want to pass the output. There's like a pass state. There can be a wait state. Say I need to wait for Textract like 15 seconds. I don't know, or 5 seconds, like something like that. Or the parallel processing on the right side. So there's a number of different states that we can choose from. And I really like how you mentioned, like, let's pretend I'm totally non-technical but I'm a business expert. Working side by side with non-technical stakeholders, this is a great tool because it lets you agree on what's the next step going to be. How do we get to the bottom of this? And it allows that collaboration. So, that's the step flows and that's the workflow in a gist. And our demo will show you a few different more options we have with the types of states. The next slide, I just really want to call out that another major perk of step functions is the existing integrations to like 15 or 16 different, over 15 AWS services and growing. That is great. That means you don't have to worry about like the SDK and the plumbing and getting the separate services, working perfectly. It's a lot of important services are already integrated, and that saves a lot of time and effort. So, I won't go through them all, but there's 15 plus here. Over to you, Mike.
Yeah, the great thing to remember about this is each one of the states input is the output of the previous state. So SNS output, whenever you call SNS, is input to the next state. So whenever you start building applications, serverless applications, they can start to get complex really quickly. Serverless is rarely like just a sequential step of events. There are multiple decision paths. You have to respond to failure. There can be downstream issues like timeouts. And you could build all this into your workflow, as we did on the left here, and manage your state with something like SQS. But step functions allow you to extract this logic to a higher level. And it also gives you a visual representation of moving through the state. So in the example that Aiden gave just a moment ago, whenever the product manager's like helping develop this project and he's like, I don't know, something's failing somewhere, he can pull up the console himself and look at this diagram and see exactly where the process is falling down. This slide sort of shows how you can reduce some of this operational complexity by you letting step functions handle this decision tree and when you're going to wait for how long. It can also handle exponential backoffs as well. So it's a great tool to simplify things. AWS Step Functions is serverless and works really well with other services like AWS, SNS, SQS, and more. But what's really neat about Step Functions is that it also enables you to interact with services beyond serverless, like an on-premise container. Activities enable you to orchestrate a task running in a different machine called a worker. And this worker could be anything that has a HTTP interface. The worker can be hosted in Amazon Elastic Cloud Compute, ECS, mobile devices, basically any application that can make an HTTP connection hosted anywhere. When a step function reaches an activity task, the workflow waits for the activity to poll the step function for a task. And then once the task is available, the activity receives a response from the workflow input along with a task token, which the activity will then use to complete its work. And then when the activity completes its work, it can provide a report of success or failure back to, and the associated token back to the service. So next, we're going to jump into a demo. Before we do that, Rob, any questions from the audience or anything on your mind?
So yeah, just on my mind, don't have any questions from the audience. So I'll remind the audience again, please feel free to post your questions there in the chat and I'll pass them on here to Mike and Aiden. But just in general, Mike, can you tell me, or Aiden, I'm concerned about or curious about HIPAA compliance, and I'm just kind of wondering if Step Functions is HIPAA compliant.
So yes, it is HIPAA compliant, and there are a number of other compliances, constantly growing, and the landing page FAQs. I think the last place I saw the HIPAA compliance or the compliance is supported, but yes, that's a definitely yes.
Great, thanks, Aiden. I wanted to ask that. Appreciate it. Back over to y'all.
All right, let's jump into a demo. All right, so we'll go and grab the Step Functions service here. And you can see a list, as I'm sure you're used to with Amazon services, see a list of the states I currently have and create a new state machine. This is kind of what one looks like here, but we're going to run a sample project. We have, Aiden, 25, 26 sample projects that can help you get started here.
Yep.
Yeah. Yep. So we'll use this one that helps us choose whether we need to buy a stock or not. So this thing over on the left here is the Amazon state language, which is a JSON state language that can that defines all our states. And this is a CloudFormation template that's going to build an SNS topic, few Lambda functions, state machine, SQS query. So we've started the stack, and it's going to take about 10 minutes. Through the magic of demos, we're going to reduce this 10 minutes. Here we go. All right. Oh, wow, that sped through. All right, starting the execution. So we can actually watch the execution of this flow through. Right now, it's asking about human approval for the stock, and you can kind of see it as it's moved through these different states. Here we can see steps of the actual state. This is what this step input was, and this was the starting state. So this is what I took to begin with, and it went and got the price. And then that input was that output was the input to the next step. And then to the next step, we'll jump into this human intervention thing. And then we make a decision whether we want to buy or sell. And again, just each input is the previous one's output. And then we get a result from the whole execution, and that gets sent back to the call-in function. You can see all the logs in CloudWatch logs. You can also have access to where Lambda actually spit out the results from each one of these different things. So let's see. We could hit the edit state machine, and this allows you to edit the Amazon state language. So as you can see, I'm just calling an ARN in here for which service I'm going to be calling and what the input is like and what the output's like from this particular thing. Let's go take a look at one of these Lambda functions just to see how an integrated Lambda function looks. We'll grab the human approval. So pretty general, this particular thing doesn't actually do human approval. It just passes the task token and sends back approved every time here. So not a super complex Lambda function, but just a Lambda function, just the same as you've seen with Lambda functions before. And let's jump back into the step functions here. And this, you can change how exactly you are, what you send in to the state function here. I'm going to choose GameStop, and see how we go here. And should we buy or sell GameStop? Oh, looks like it's a buy situation here. No forward-looking statements here. There's also this new data flow simulator that can orchestrate how you send the data through the system. This is a new feature, and it allows you to simulate different inputs and outputs. Really excited about this new feature. And that's it. So Aiden or Rob, if you guys want to, if there's any questions or anything going on now.
Yeah, so just one quick question from the audience. Just wanted to know about difference between Lambda functions and step functions. Just asking if they're two separate things, or if you can give a little bit more information about those.
Sure. Lambda functions versus step functions. So Lambda functions is where you run your compute, your actual code of your application code, in Python or C# or the actual software that you're looking to run the logic of, your service logic. And step functions is like the glue between Lambda functions, and it allows you to pass the input and output states. It allows you to make sure that you had a successful execution, and you met what you were looking for before it talks to the next Lambda function. And it helps you tie in 15 plus other AWS services. Like if you wanted to have an API gateway, to have external external HTTPS calls, for example, or an SNS topic to alert to like an SMS, like a phone number, right? So that's what step functions is doing. Lambda functions are probably one of the most common services you'll integrate with step functions, but they're definitely distinct functions you can make use of. Mm-hmm.
Thanks, Aiden. Appreciate that. Back over to y'all.
Sure. So really quick on this topic, resiliency, right? Step functions really helps with resiliency because it has the native capability defined in your Amazon state language, that JSON file Mike was showing there, to actually specify like the retries, number of retries, and exponential backoff built in. That's an algorithm that says you'll wait a little bit longer if you get like a 5xx, like an error somewhere in the pipeline. And this retries and backoffs are usually code you'd have to build yourself or take advantage of from like our SDKs. But having this built in automatically through step functions helps with that resiliency that you're looking for, and gives you a more reliable application. So yeah, in this case, if the billing the customer failed, it can retry automatically shortly without them knowing in the background. They don't have to care that there was an error. They'll get the end result that they're looking for. So yeah, that's that in a nutshell. Now I wanted to, Rob, you'd asked a question earlier about like kind of mixing and matching workflows, and I think this slide and the next slide will answer that viewer's questions. And really, there's two major types of workflows. There's the standard workflows, which is ideal for really long running, durable, auditable workflows. Like we're talking up to 1 year, this workflow can run here, and whereas Express can run up to 5 minutes, right? So totally different, immediately off the bat, different use cases there. Standard workflows are suited to handle non-idempotent actions, like processing payments or starting up an Amazon EMR cluster. Like, just to explain that, like, non-idempotent, I mean like, making multiple identical requests does not have the same effect as making a single request. Like, payment processing. You don't want to end up charging the customer, more than once for a purchase. They would not be happy. So if you need that extra durable safety, stick to the standard workflows for those. Like if your code is not, if idempotency isn't factored. But for Express workflows, this is a newer addition to the type of workflows, ideal for super high volume event processing and that less than 5 minute lifespan there. And from last reInvent, we announced or we released synchronous Express workflows as well. So this is an extra layer of, previously it was asynchronous for us. So we, basically chaining and waiting for the results. Like in a shopping cart experience, you may want to wait for the previous result, like confirm inventory before moving on to the next steps. We'll explain it in the next chart here, but if your workflows are suited for Express workflow, the pricing is a little lower for Express workflows, and it's also billed per the duration. So if they're tiny, like microseconds or whatnot, you'll get some pricing benefits from the Express workflows. But if not, the standard workflows are a great option. Yeah.
Great. Hey, Aiden, before we move forward real quickly, I got a question from the audience here from Bravery65 about those workflows. Is the code for workflows generally generated via like a template of some kind, or how do those get created?
That's my advice, is to start with the templates. There's in the demo you saw like 20-ish different sample templates there, and I say don't reinvent the wheel. Have a look for inspiration, see what is in these templates. There's really clever ways that that a lot of things have been solved before, like launching the EMR clusters, doing some of that extra work. So check the templates out, but of course, totally feel free to edit them, and you can launch as well via CloudFormation templates, via SDKs or CDK. But yeah, start with the templates and then make it work for your workflows is my advice. Mm-hmm.
Great. Thanks, Aiden.
For sure.
Yeah, and just to go a little bit deeper here, standard and Express workflows are built for two different types of workloads. You should use Express workflows for workloads with high event rates and short durations. Express workflows support event rates of more than 100,000 per second. Express workflows have a maximum duration of 5 minutes. They guarantee at least once execution. Failed workflows must be rerun from the beginning. Express workflows support all service integrations, but Express workflows do not support activities, job run sync callback patterns. Job run sync callback patterns for integrated services like AWS Batch, Amazon ECS. Step functions can wait for a request to complete before processing the next state. And to have step functions wait, specifically the resource field in your task state definition with the sync suffix appended after the end of the resource URI. Standard workflows on AWS, step functions are more suitable for long-running, durable, and auditable workflows, where repeating workflow steps is expensive, like restarting a media transcode, for instance, or harmful, like charging a credit card twice, as Aiden mentioned. So I'm going to jump into one more case study. Coinbase is a managed wallet and exchange platform for cryptocurrencies. The Coinbase team identified an opportunity to improve their automated deployment pipeline to increase deployment speed using AWS Step Functions and Lambda. In doing so, the team simplified their architecture, improved visibility for their engineers, and simplified auditability. They reduced the time needed to add new AWS accounts from days to seconds. And also they used a single step function to enable multi-accounts, providing them with a single audit trail for all deployments. They can now enable new accounts with high security without needing to re-implement an audit trail. And they also noticed a significant reduction in trouble tickets about failed deployments, because the engineers can actually see where the deployments failed in the actual state. There's a case study reference. I have a link to that. I think I sent that over to you, Rob. If you could post that into the chat, would be good. And Aiden?
Yeah, thanks, Mike. So, just circling back here, I want to get to like bottom line statements here. Step functions, if you're working with distributed apps or microservices, like modern applications, this is an awesome service to help with all of your data processing workflows, your machine learning workflows, orchestrating your apps, and even like your security and IT automation steps. And we went over all these details, but I really wanted to drive home There's a ton of use cases for this thing, for step functions to, really improve your workflows and help orchestrate and give you auditable, easy to view processes in the end result. So, let's help you get started today. And, this first link will give you all of your use cases and pricing and your details there. Serverless land is awesome for training and for actually like applying a lot of the features. There's a lot of features in step functions we haven't covered, but all the different use cases and templates. I think Ravery 65, that's a great place to check out, see the blogs there. And lastly, there's a lot of different workshops, like this little unicorn serverless land, workshops to help you apply and get going with step functions. So perfect. Yeah. Over to you, Rob.
Great, thank you. Spend a little bit of time. Is there anything else that you'd like to share, just about the step functions? You kind of went into some information there, just to kind of highlight some of the ways to get started and working through that. Anything else you just kind of want to add in general from Mike or Aiden?
I would say generally, just it's hard to say how much better this is than sort of spaghetti code that calls one thing and then something else calls something else, and then everything's calling things all over the place. To be able to see this workflow in just one visual place is just amazing. It's awesome to be able to, debug. I think several times whenever Aiden and I were going through some of the project, we were just delighted, and it was just fun to be able to debug things in this way. Also, something that is a pretty cool way to get started with step functions. There's a trusted advisor way to be able to integrate trusted advisor in with step functions, and it's a super cool way to be able to get started and something that can immediately add value to your team and be able to see things work together. If you search that up, Rob, I don't think I gave you the link to that, but I can post that up in some a little bit later. But you just search up trusted advisor step functions. It's a reference we have out there.
Yeah, I pasted that into you here. It's Trusted Advisor
Great.
Explorer,
Great.
which is awesome. I mean, it takes like 30 different steps, and it is a template, so you don't have to build it yourself. But it really makes it, I'd say, much more useful than just using it directly, and it adds an extra value for you with Trusted Advisor. I guess maybe I have one to add as well. Like I would say before step functions, like I think some of us might remember like UML modeling, like that unified modeling language. And again, like being able to have everybody look at the whole workflow diagram and visually see if there's any failures, like even non-technical people can make sense that we're having failures and a lot of retries at this step, is a huge benefit. I'd say is one of the best features of step functions. And Mike, if you go a couple slides extra into the appendix, I wanted to call out that like there's immediate there's very friendly ways to develop with step functions, like the serverless application model SAM. If you want to work in YAML or JSON declarative templates there. There's the CDK if you're very code centric, and all of our SDKs like are supported here. So even our data science SDKs. And the next slide, I mean, just like building locally. The console's great, but a lot of people's IDEs, they want to work in their IDE directly, and having like direct plugins to like Visual Studio Code, you can actually display the same diagrams there. So if you don't want to work in the console, right, all the time, you have the options for local development as well. So just a few more callouts there to help you get started.
Great, thanks, I appreciate that. Thanks, Mike, for the information. So everyone, today we looked at AWS Step Functions and how they can streamline and simplify some of your workflows. and really help you automate and kind of, orchestrate your serverless environments. If there are questions that were not answered today, you can post their questions on forums.aws.amazon.com, and you can email us your feedback at awssupportsyou@amazon.com. We want to hear from you. Tell us what else you would like to see on this show, and thanks for joining us again today at AWS Supports You. Hope you have happy cloud computing. Thank you all.
Thank you.